Hello, I'm John Gertz, SETI theorist, and today I want to summarize what we've talked about in the Drake equation and then wrap it up and put a bow around it and then toss it into the ash heap of scientific history. Okay, let's start with looking at the equation again and taking it factor by factor. We know now that R prime or R star, whatever Drake wanted it to be, however Drake wanted it to be pronounced, is useless. We don't care about the current rate of G star formation at this point in the history of the Milky Way. Utterly irrelevant. What is relevant is the number of stars in the Milky Way. We know that to be between 200 and 400 billion stars. But that doesn't account for all the space in between the stars. And in between those stars, there are rogue planets, there are brown dwarfs. There could be the cruising world ships of alien civilizations that are cruising interstellarly among the stars in the galaxy. And most importantly, according to my theories, within our own solar system, we could find alien probes transmitting to us from any direction. So effectively, we've got to cover all spots on the sky. Well, all spots in the sky means it's an infinite number of spots, but infinities, if you add an infinity into any factor of the Drake equation, then the entire equation turns out to be infinity, because infinity times anything else is still infinity, and n becomes infinity. And we know that although it's a large galaxy, you can't have an infinite number of alien civilizations. But the saving grace is that what we're really looking at are discrete areas of the sky or spots on the sky, and that's a dynamic. There's not a single number that fits that, because it depends on the aperture of the telescope that you're looking through, or with, if it's a radio telescope. Essentially, telescopes, effectively, the larger their diameter or their aperture, in most cases, the smaller their field of view. So we can't really tell you how many spots on the sky there are without knowing what telescope you're looking for. But the correct way to do SETI is to mosaic the skies spot by spot or area by area. Okay, so now onto the F sub P, that fraction of stars that have planets. We already know it equals 1 or more or less equals 1, can come right out of the Drake equation. All stars have planets for all intents and purposes. On to the next factor, N sub E. N sub E, that's the number of Earth-like planets in a particular solar system. But we don't care about the Earth-type planets, specifically Earth-type planets, because life can arise on a comet. It can rise, on a rocky planet without an atmosphere, very close to its sun, like Mercury, or very far away from the sun, like Pluto in its sub-ice oceans, or anywhere that you have a thermal vent, a tide pool, a puddle, a pond. Anything becomes its own little petri dish. And how many are there in a solar system? Well, I don't know. I mean, it could be 1 trillion. If you look at each little pond and tide pool as its own little petri dish, and not just in slice of time, but over time. So one pond dries up, another is formed. Each one becomes its own little microcosm of a place where life could start, sui generis. So essentially, if you take, the total number of such places in the solar system, and multiply it times the fraction of those places in which life may form. So the number of places is very large. The fraction of could be very small, but it probably comes out to approximately 1. I'm saying that because the alternative is that life is so miraculous and so hard to develop or to emerge from prebiotic chemistry, that even given 1 trillion opportunities, it never happens or almost never happens. In which case it's approximately 0. Well, since we it's got to be either one or zero or something very close to one or the other of those extremes. Since we're SETI scientists and we're going to fudge it and say it's one and not zero, because if it's zero, the whole Drake equation collapses. But if it's one, as we know with other factors that are one, can come right out of the Drake equation. So uh, so n sub e and f sub l together, when taken together, equal one or approximate one, and can be taken out. So much for them. Okay, f sub I. Well, SETI is not the search for intelligence per se. Uh, Squid, orcas, ravens, they're all intelligent, but they're unlikely to ever become detectable by virtue of any technological byproduct of that intelligence. Even in the far future, they just don't have the the appendages to manipulate to make tools. Well, ravens do, but nonetheless, it's and octopuses do as well. But we can't imagine them really. Even as we can imagine their evolution, we can't imagine them developing the technology that can do SETI. So SETI is a search for technological civilizations that can be detected. But if they can be, but their detection is a function of how far away we are from them and how strong their detectability is. In other words, if we're looking for their city lights, how bright they are, um, and uh, and it's a function of how capable our detectors are. So it's a dynamic, and so I would prefer, and I'm going to say, let's substitute f sub I for f sub d, the fraction of civilizations that are detectable by any means whatsoever. And Now we'll come back to that in a second. Drake's L can come out of the equation altogether, because the life we're likely to meet, or most likely to meet, is probably robotic life, if you can call it life. And I'll leave that to you, to each of us to decide for ourselves. But if we meet an AI probe in our solar system, it may not be contemporaneous with this progenitor civilization. That civilization could have gone extinct a million or a billion years ago. So there's probably some correlation between N and L, but it might be quite low. So this leaves us going back to F sub D, is really what it's all about, the fraction of civilizations that are detectable by any means. But actually, I would prefer to, scratch that and rename it P sub D, which I would call the probability of detecting ET with each pointing of our telescope. Ah, now I'm going to take big credit for that. I've invented a new factor, uh, P sub D. Let's call it the Gertz factor. It might in fact be the very philosopher's stone of SETI. Astronomers and the public could pay me great homage for having now developed this great new factor. Dozens of doctoral dissertations might be written upon it over the next few decades. Unfortunately for my would-be fame, P sub D, like Drake's N or Drake's L, also cannot be determined by any means whatsoever other than observation. It's precisely because neither the Drake equation nor this new fantastic Gertz factor can be solved in the absence of any observation that SETI is actually important. Even um, even if we could somehow miraculously know Drake's N, or even if we could miraculously know for a fact what P sub D is, it would make no practical difference. We'd still have to, as SETI scientists, plow through the stars or the targets one by one and as I suggest, mosaic the sky, field of view by field of view by field of view. And paradoxically, It is precisely because the Drake equation can yield no solution to n that I'm such a fan of SETI. If f sub I and f sub d and especially L are unknowable through any other means other than experimentation, and SETI is that experiment, then we should just dump the Drake equation and be done with all this foolish crazy making and get on and run that experiment. That's my message for today. Excuse me for my exasperation. Anyway, I'm John Gertz. You can visit me at johngertz.com, which will direct you to my more elaborated papers and maybe when my book comes out, Reinventing SETI, you take a look at that. Okay. Until next time, thank you for joining.